Hello everyone, and welcome to the fourth and final part of the demonstration for the threaded shaft project for Machining 210 at Laney College. Your part should look something like this right now, and so this final part is going to be putting the threads into the part. This is the print that we're going to be looking at. The print itself only has 2 thread specifications, but we've given you this additional thread data that we went over in the second lecture for this project that went really in-depth into threads and how to make them and measure them. Okay, and this time we're going to actually make them and talk about some of the finer points of how you have to set this up. Here's the project planning worksheet. Stage 3 for threading has actually a separate project planning worksheet for it, and we're going to be following this really closely. We're also going to be using the operations manual. The operations manual has a very useful section on cutting 60-degree external threads. Okay, it's like 3 pages long, and at the end here it's got this chart that actually talks about the depths of cut and how many passes you're supposed to take over the part to generate the threads for various different pitches. And we're going to be looking at this very closely to determine how many cuts we're supposed to take on our actual part. Okay, so make sure that you've got that out as well. There's quite a lot of setup work that goes into making threads. Okay, so we're going to start with step number 1 right here, which is adjusting the compound. So we're going to adjust the compound to 29 degrees. Okay. And it's very important that you set it to 29 degrees from the correct direction, okay? We're going to be adjusting at 29 degrees from perpendicular, like this, right there, okay? We're not going to be adjusting it 29 degrees from parallel, so that would be something like that. This is not the correct angle, and if you set your compound to this angle, then you will not be able to generate good threads on your part. Okay? Actually, you're going to end up making something like a buttress thread because one side of the thread form is going to follow the angle of your compound, right? And then the other side is going to have the 30 degrees from your thread, and so your threads are going to look something like that, right? With like a more vertical side on one flank, right, and then a much more tapered side on the other flank. Right? So that's almost like a buttress thread. Okay, it's a very, very, very common mistake to make. Don't make it. So again, just to reiterate here, we're going to go from perpendicular to 29 degrees using this chisel mark right there. Just line that up as absolutely best you can. Okay. And then lock it down. Okay. In order to explain why it is that we set the compound to 29 degrees, or why we even cut on the compound at all instead of just with the cross slide, I think it'll really help to have some graphical visualizations here. Okay. So this first one right here is if we were actually to not go in on the compound, but rather go straight in on the cross slide. Or let's say we set the compound up at 0 degrees, so it's perfectly perpendicular to the spindle axis, and we were going to go straight in to the threads like that. So every time we took a depth of cut, we would go straight in like that. So let's say this is 0 degrees. So each one of these dark bluish, purplish lines represents one pass, okay? So every time we take a cut on the threads, all right, this is showing us how much material we're removing and where it's coming off. So if we're going in on the cross slide or at a 0 degree angle with the compound, then all of the material is going to be removed equally from both sides of the threads, okay? Because the cutting edges are going to be cutting on both sides, meaning both cutting edges of the tool are going to be removing material, okay? Now, this is fine, okay? But the problem is that the deeper we go and the coarser the pitch of the threads, the more material we're going to be removing, and so the broader and broader and broader the cut is going to become. So then we start running into issues with deflection of the tool. We start running into chatter problems. We start running into issues of the tool biting. We start running into tool wear problems, right? So the point is that this is such a large forming cut that we really don't want to take so much material off of both sides. There's going to be too much of the tool engaged this way. You can get away with this with like very fine pitch threads or very, very soft materials, but in something like steel, you're really going to want to find some way to reduce the amount of the tool that's actually in contact with the part at any one time. And that's where this comes in, okay? In this case, what we're going to be doing is we're going to set the compound up to an angle of 30 degrees, all right? Notice that the tool is still facing the same way, but we're going to be feeding the cutting edge, right, at that 30-degree angle, exactly 30 degrees. So now the tool is going to be following the right side of the threads like that, okay? So now all of the material is going to be coming off the left side of the tool. So we're still cutting the same thread form, but we're just following the right flank of the threads right there every time we take a depth of cut, right? So we basically just halved our tool engagement. This is kind of an ideal scenario here, right? If you're set up at exactly 30 degrees, then you're going to be following the thread form exactly, and you're only going to be cutting on the left side of the tool. But, you know, if we're just using the lines that are on the compound, it's pretty difficult to get it set up to exactly 30 degrees, right? And so you can run into being a little bit over or a little bit under 30 degrees. Let's see what happens if you're at a little bit more than 30 degrees. Okay, in this example here, let's say that we're at 31 degrees. 31 degrees, right? Now every time we take a cut, we're going to be feeding at an angle greater than what the profile of the threads is. And so actually, we're going to be creating an angle on the right side of the threads, which is greater than the included angle of our cutting tool. And it's not going to be a perfectly uniform surface either, right? Because every time you take a cut, you're going to be kind of creating this jagged surface everywhere where the cutting tool engages, right? So this is definitely not what we want. Being over 30 degrees is the worst case scenario. The next best thing to being exactly 30 degrees is to be slightly less than 30 degrees. So let's say now that we are at 29 degrees. In this case, we are going to be cutting on both sides of the cutting tool, but we're going to be cutting way more on the left side than on the right side. So with the compound set up at this angle, we're guaranteeing that we're going to be cutting the correct thread form, right? But we're also getting the advantage of mostly cutting on one side and reducing our cutting tool engagement, okay? So that's why we set it to 29 degrees. Actually, it could be any angle as long as it's exactly 30 or a little bit less than 30. It could be 29 and a half. It could be 28, actually. But we just set it up to 29 degrees because that's easy to do, and also because that's what the numbers in our operations manual are based off of. Okay, I hope that that makes sense. Okay, the next thing we have to do is just make sure that the compound rest and the compound slide are more or less flush up with the ends. And also we're going to want to zero out the dial on the compound itself, okay? We're going to be taking some, okay, so there it is, 0 lined up with the chisel right there. And so we're going to be taking or adjusting our depth of cut with the compound, okay? So we are going to need a starting position here. All right, operation number 2 is to actually install the threading tool and adjust its height to the center line of the lathe. But before we do that, we have to just verify that our tool is correct, okay? So for this project, you should have ground your own threading tool out of high-speed steel, okay, with a 60-degree included angle. And in order to measure that, we were just using the protractor, right? So you could just set it to 60 degrees and use it as like a visual reference there. Okay. This is pretty good. It's pretty close. But it's not as close, I think, as we would really want to go with this. One other thing that you can use, by the way, is this little center gauge, which we're going to talk about in a little bit because we're actually going to use this to align the tool on the part. But suffice it to say that this little gauge has a bunch of 60-degree angles in it, and you don't actually need a protractor. You could just use this for both alignment and for grinding, because you could just grind your tool to match one of these 60-degree angles. Okay, so that's also a possibility. Still, I think we want to get a little bit closer than that and use something more than just a sort of naked, unaided eye visual inspection of this tool. Okay, so in order to do that, we need to go over to the optical comparator. Okay, on the optical comparator, and we should have gone over this when we're doing our tool grinding, but it's good to just double check it now, and you should definitely do it if you didn't do it before. On the optical comparator, we're just going to set our tool down on the surface so that our tool is on its side, so we'll be able to get at that 60-degree angle. Okay, I'm going to go ahead and turn this on down here. So hopefully you can see what's happening here, that there's a light which casts a shadow of the part into this magnifying lens. Behind the magnifying lens, there's a mirror that changes the direction of the image and projects it up onto the screen. All right. Now, because this is just very simple optics, everything's going to be upside down. There's no correction for that. Okay. So just bear that in mind. One thing that we really need to make sure of is that our tool is square to the sort of path of the image, okay, the path of illumination. And so really, you could do it by eye, or we made this little, I don't know what you call this, a little stop, okay, that you can use in order to just make sure that this is square to the T-slots right here, which is going to be good enough for us. Okay. There are a number of controls on here. So this moves the table left and right. This moves the table in and out. This moves the table up and down. Okay. So this handle and this handle are for kind of positioning the image inside of the screen. But this handle right here is for focusing. And you can see as I move it around, I get a sharper and sharper and sharper line. And we want a good, crisp, sharp line that we can compare. Okay. Do be careful when positioning this because it's very easy to run the table into the lens. And that would obviously be a problem. Also remember that there's a little lens cap on here that I removed, and of course at the end I'm going to put it back on to protect the lens. Okay, so in order to inspect these cutting edges, right, I'm going to need to change the angle of the scribed lines on the chart up here. So there are actually degree graduations all the way around the chart, okay, 360 degrees, right? And then down here you've got a little 2-minute vernier scale, and this is where the 0 is, okay? So we're not going to bother with the vernier scale. We're going to be looking at the main degree graduations and maybe even subdividing them, okay? But this 0 right here is going to be our reference. So when the 0 here and the 0 here are lined up, then this scribed line is vertical and this scribed line is horizontal. Okay, so we are looking for 60 degrees between the two cutting edges, or 30 degrees from horizontal on both sides. Okay, now it doesn't really matter what the angle of the cutting edge is relative to the rest of the tool. Okay, so it doesn't need to be square with the sides of the tool. They only have to be 60 degrees relative to each other because we're going to align this on the machine when we actually get there. But just to give ourselves a starting position, we're going to go for 30 degrees from one side. Okay, so now I've lined the 30 up with the 0 right there. Okay, and I'm going to go ahead and look at the top angle. I hope that you can see just visually that line is very parallel to the cutting edge, okay? And the closer you move it, the finer you can resolve that, but it's looking really good, Okay? And it's not just that it's got the right angle, but you can also see that the cutting edge is very, very, very straight. And that's something that we want. Okay? We want good straight sides, straight cutting edges, and we want them to be at the right angle. Okay? And it's actually most important down in this area right here, okay? Because that's where we're actually going to be cutting, right? So remember that everything that you have on your tool, whatever any like little nicks or waves, or if the angle's not right, any kind of error in the form of your tool is going to be transferred to the thread form of your part. Okay? So it's got to be perfect. All right. Now let me go ahead and adjust this 30 degrees the other way. So from 0, I'm going to go minus 30. So I'm going to be at the 330 mark. All right. And now let's compare the other side. Okay. The other side also looking very, very straight, which is great. It looks like I guess the gap on this side of the cutting edge is a little bit smaller than the gap over here nearer to the tip of the tool. So let's now adjust the chart a little bit until it looks like it's parallel, and then we can go back and read the degree mark. So that's looking like, yeah, a half of a degree below 330, right? So if we were 30 degrees for one cutting edge, and then we're a half of a degree over 30 on this side, all right, then that means that we're actually at like 60 and a half or so degrees on the actual cutting tool, all right? So we would like it to be exactly 60, right? But like a half of a degree is going to be okay. We will still be able to get the form close enough so that we can make threads which meet the size tolerance for pitch diameter and have the correct form, or correct enough form, if we have a half of a degree off on our included angle. That's going to be okay. Okay, so this is what you're looking for. Okay, moving right along, now we can actually set this tool in the tool holder and adjust its height. Okay, so just for now, I'm going to put it in at, it doesn't really matter what the position is, just to get the tool height. And maybe put one set screw down, just so I know that it's in position. Move that tailstock in so I can get access to the live center. Yeah, the live center is really my preferred method of adjusting the center of tools. There are quite a few different methods. Okay, there we go. Looking very good. Okay, now I'm going to move it back over to this position. All right, so let's go ahead and put the part back in. Again, everything should be really nice and clean on the part and also on the fixturing devices, the centers. Also remember that if you're coming in for your first cut of the day and you had to break down your setup last time and you're setting it up again anew right now, then you're going to want to make sure that you take a skim cut on your dead center in the spindle. Okay, this looks like, am I going to be able to get access everywhere? Oh, yep, I am. Okay, so I'm going to lock the tailstock down. Then I'm going to give myself a little bit of tension on there. We're not going to want that to move around. Okay, that looks really good. I mean, it's still, I can still move it with relative ease, right? But it retains its position. That's what we're really looking for there. Okay, so now we're going to align the tool. Okay, same rules are going to apply for aligning this tool as applied to aligning the grooving tool. Okay, so I'm going to put a little bit of a white background. It's just, again, that notepad that we give everybody. I'm going to put that behind the tool so that I can see everything a little bit easier. Remember, I mentioned that we're going to be using this tool right here called the center gauge. Okay. And so 60-degree angle here, but it's an external angle. Then we've got 1, 2, 3 60-degree angles here, and those angles are very, very square to the rest of the body of the gauge, right? So this is also sometimes called a fishtail gauge, because it looks like a little fishy swimming through the sea. Anyway, so I usually use that larger angle right there, okay? You can use a smaller one, but it's a little bit better to use the bigger one. I've got one of the set screws, the front set screw on the threading tool. I mean, not tight, but snug, right, so that I've got a little pivot point right there, okay? And all I'm going to do, if I can figure out how to hold this thing. Oh, how about this? Okay, so bump up one side of the center gauge up against the diameter on the part, okay? And then we're going to run the tool in so that it's pretty close, and we're going to look at the gap between the tool and the angles of the center gauge. And I kind of give myself room like this so I can look at both sides. So I got a gap on both sides there, okay? And all we're going to do is adjust the tool until it looks like it matches the angle on the center gauge when the center gauge is pushed up against the diameter, right? If the center gauge is off at an angle, I mean, all this is going to be thrown off, right? But so let's see. Let me set this at a bad angle so you can see what that looks like. So that's obviously not the correct orientation, right? Because the gap is not even, you know, from one side of the gauge surface to the other side of the gauge surface, right? So it's not even from this side to this side. It's actually smaller over here and bigger over here. Anyway, I knocked it out of position. Probably a little bit too loose there. Okay, all we're going to do is rotate this until it looks like it lines up. Okay, so actually I think in this case the white background is not helping us. So let's look at that without the white background. Okay, I mean that looks pretty good right there. Remember that our tool is not exactly 60 degrees, so it's not going to line up perfectly. But you got to get it as close as you possibly can. And that looks pretty good to me. So let me tighten this down and then we'll double check it. Yep, and that definitely looks good to me. Okay, so now everything's good and tight and we are aligned to the part, so we're ready to go. All right, that was step number 3, aligning the threading tool to the part. Now we've got to set the gearbox for the correct feed rate, okay, for threading. Remember that basically what we're doing here is we're going to set a feed rate that is equal to the pitch of the threads, right? So remember that feed rates are given in inches per revolution, right? And so so that's telling us that every time this the part makes one full revolution, we're going to move a certain distance. Well, that's the pitch of the helix on the thread, right? So if this is going to be a 3/4 16 thread, the TPI, the threads per inch, is 16. The pitch is 1 divided by 16, so 0.0625. And so every time this thing comes around, we're going to need to move 0.0625, and that will create a helical path that has the correct pitch. But the way that the chart for the gearbox is marked, it doesn't give you the inches per revolution feed rate. It gives you the actual threads that you're trying to cut. So let me show you that. So we've been over here for this entire time, right, looking at inch feed rates, okay? Over here we've got some worm gear settings. We've got metric threads over here, but this is what we're going to be looking at now. This is for inch threads. And you can see that it starts off at 2 threads per inch, goes all the way up to 12, then comes back around here for 13 to 72. Okay, so 72 threads per inch is the finest thread pitch that this can cut, and 2 is the coarsest. Okay, we're going to be over here at 16. All right, so that's LBS1V. LBS1V. We're also going to be cutting an 11 TPI thread, so that's 11 right there, so that's LBT4V. Okay, so that's like the special combination to unlock the threads per inch you're trying to cut. Okay, so 16 LBS1V. L for low, B, S, 1, and V. Right there, okay? Now that that's set, the next thing we're going to do is double check to make sure that we've got it set correctly and simultaneously touch our tool off on the part so that we can establish a reference point for starting our depths of cut and passes. So I'm going to set this up to the correct speed, which is something that you should have already figured out. So the speed is something that you can actually play around with, okay? Because here we're not just limited by what the tool or the setup can handle, we're also limited by our own abilities, our own reflexes, okay? So when we're threading, this is going to be a really fast feed rate, okay? So things are going to be happening very quickly, and there's quite a bit of timing involved, right? Not only when do you start the threads, okay, but also when do you disengage them, right? And we have this little 1/4 of an inch window right here to stop the tool before we slam into this shoulder or the lathe dog, okay? So if you need to slow it down, remember that the feed rate is geared to the speed of the spindle, right? It's all dependent on revolutions of the spindle. So if you slow down the spindle, you slow down the feed rate. So you can do this if you need to give yourself a little bit more reaction time. That's totally okay. Okay, I'm going to go ahead and turn this on. Get some Dicum, shake it up. Okay, blew up the surface. Okay, while that's drying, I'm going to do a quick spin test. Okay, just to make sure that I'm not, I had this problem last time where I made the rookie mistake of not doing a spin test, and see, I probably would have done that same mistake again here. Okay, so I'm actually going to have to go in and bring the tool out a little bit, and then I'm going to have to realign my tool. I'm going to do that off camera because you don't need to see that. Okay, there we have it. Brought it out a little bit and realigned it. So now let's check our clearance here. This is about as far over as we can go anyway. And that's going to clear, yeah. I mean, we're going to slam into that shoulder before we slam into the lathe dog, right? So, I mean, if we've got one problem, we're going to have another, so I think that's okay. Remember, the other thing that you could do is you could move the position of the lathe dog, right? You can move that over a little bit and readjust it on the set screw. Just be careful that you should not do this after you've already started taking your cut, okay? Because if you change the position of the lathe dog and then you retighten it, right, then you're going to index the position of the lathe dog relative to the part, which is also going to index your threads relative to the machine, right? And then your tool and your threads aren't going to line up, and so you're just going to blow out those threads. You're going to do what's called cross-threading, and you're going to just absolutely destroy it, okay? So there's a lot of very delicate repeatability that we're trying to accomplish here, okay? So anyway, that's looking good to me. All right, so the Dicum is dry. Let's go ahead and turn that back on again. Okay, and I'm going to go ahead and feed this in so that the point just scribes a tiny little line in the blue Dicum on the surface. Nice and slow there. Oh, there we go. All right, and then I'm going to zero out the dial on the handle of the cross slide, okay? So the compound is at 0, the cross slide is at 0, okay? So now what I want to do is go in maybe 2/1000ths of an inch on the compound, okay, just to take a little bit of a cut to scribe the line. Actually, it may even be appropriate to take a cut right now, right where we are right now, because I did a slightly heavy touch off on there. Okay, so as long as we're cutting a scribed line into the Dicum, then we're going to be able to accomplish our end goal here, okay? Actually, let me go ahead and stop this so I can show you something. So in order to cut the threads, we're not going to engage the feed lever, okay? So this actually has nothing to do with threading. Neither does this down here, the plunger that changes the direction, okay? Because we're not going to be grabbing onto the feed shaft down here. That's not what we're going to be grabbing onto, okay? We're actually going to be using the lead screw, the proper lead screw on the carriage, on the bedways, okay? This lead screw here is only for threading, all right? And so when we adjusted our feed rate on the quick change gearbox for 16 threads per inch, you should have noticed that the lead screw started spinning. So let me show you. Okay, so now the lead screw is spinning as well as the feed shaft. In order to grab onto the lead screw and start feeding the carriage based off of that, we're going to use this handle right here, okay? And this is to engage the half nut. So all you have to do is, right, push it down. And that is going to engage the half nut that grabs onto the lead screw, okay? So what is a half nut? What is this actually doing? So hopefully you can see down here that there is literally a nut that is split in half, and when I engage this handle here, the two halves come together to grip the threads on the lead screw. That's what's happening. So the other part of this is what's called a chasing dial, and that's this little mechanism right here, okay, that just fastens onto the end of the carriage, and it's got a little gear in it, okay? And so that gear is supposed to ride on the screw, or rather it's driven by the screw, okay? And then that drives a little dial up here. So when you turn the spindle on, and the lead screw starts spinning, so does the chasing dial, okay? And based off of this little button right there, it tells you where in one of 8 positions you're actually engaging the half nut, okay? So this is where the timing comes in, okay? And which one of these marks you're allowed to engage on depends on the pitch of the threads that you're cutting, okay? And that information is actually on the front of the chasing dial. Okay, so for any of these threads, okay, these inch threads in threads per inch, okay, any of these, let's see, anything that's divisible by 4 here, okay, is going to be any position, right? Any numbered position or any mark in between the numbers, okay? For these even threads, okay, it can be any non-numbered position, okay? For these odd threads, it's going to be any numbered position. And this all has to do with basically indexing the start of the threads. And if you engage on the wrong position, then you're going to cross-thread the threads, meaning that you'll probably put another thread right in the middle of 2 threads, which is not what you want to do, right? You want to keep finding that thread in the same position every single time. So it is important that you follow this. Okay, without further ado, let me turn this on. All right, I'm still at my 0 position and I want to take a test cut. Now for 16 threads per inch, I can engage anywhere on the chasing dial, okay? But that means not literally anywhere, I mean on any of the numbered or non-numbered positions, but not in between them, okay? So by the way, this is something that you may want to practice a few times before you actually get into it, all right? But you know, I've done it a few times, so I'm just going to go ahead. Okay, and so I'm going to engage, let's do the 2 mark right there. And there we go. And you can see that it's following that nice helical path. All right, and get ready to stop right there. Okay, now you could see how fast that was moving. I mean, if that freaks you out, there's you know, there's no pride lost in slowing this down a little bit so you have more reaction time. Okay, I'm going to pull this back 1 full revolution so that I can get back to the start of the threads, and I'm going to turn it off. So to check that I'm cutting the correct threads, I'm going to use this thread pitch gauge. Okay, so this just has a bunch of leaves in it, and each leaf has a different thread stamped into it. Okay. They're labeled, so you've got 28 threads per inch, 34 threads per inch, 40 threads per inch. I think it goes up to 60 threads per inch. And then I think it goes as coarse as 6 threads per inch. Okay, but we're looking for 16, so let's go ahead and grab that one. 16 threads per inch, good. All right, just like that. Okay, and then all we're going to do is compare this to the threads that we've got. So if we look at it a little bit closer, this is what we see, okay? And what we're looking for is that those peaks line up with the scribe marks. And I think that they do quite well, right? I mean, you know, the best way to check this to make sure that you're cutting the right pitch is to check the leaves above and below this one, right? So the next finer pitch is 18, and that clearly doesn't line up, okay? And the next coarser pitch is 15 threads per inch, and that also definitely does not line up, okay? So 16 it is. Looking good. So the next step is to actually cut our threads, right? We're going to take progressive cuts with the compound according to the cuts in the operations manual. That's what step number 6 is telling us. So let's talk about that. So the operations manual has this really useful chart right here that gives you the depth of cut for each pass and how many passes you should take if your compound is set at 29 degrees. Okay? So it's for all the different pitches. Obviously, finer pitches, you're going to have to go, you're not going to have to go as deep into the part, right? So there are fewer passes of smaller sizes. And for very coarse threads, yeah, you're going to have to take a lot of material out of there because they're very large threads. So you're going to have to go really deep, and you're going to have to take a lot of cuts. Okay? So because the amount of cutting edge that is engaged with the part gets progressively more and more as you're taking deeper and deeper and deeper cuts, right? We're going to have to like sort of peter it off. So we're going to start off with a larger cut, right? And as we start getting deeper, the depths of cut are going to start decreasing, okay? Now, all of this is based off of trigonometry, right? Like, we're looking for a specific depth of cut. And if we were going straight in on the cross slide, well, we could just, right, touch off on the outside of the diameter and then go in until we hit that depth. But because we're going in at 29 degrees, right, we have to, what we're actually doing is we're going in a distance on the hypotenuse of a right triangle, where one of the legs is the actual, radial depth that we're going to be going into the part. Okay, so they've trigged it out for us already so that we don't have to do it. But just for your own education, this is the value right here, okay? So what the depth setting is going to end up being for 29 degrees, that's the ultimate distance that we're going to go on the compound according to the hypotenuse of that triangle, all right? So we're looking at 16 threads per inch right here, and it's telling us, so we're going to take a cut of 10, 8, 6, 5, 5, 3, 2, and 2. And then we're going to take a few finish cuts. And those finish cuts are going to be based off of the cross slide. Okay, so we're going to finish this off with the cross slide, but we're going to start with the compound. Okay, it's much easier to dial in the size of the pitch diameter if we're going in on the cross slide, because then a thousandth of an inch is a thousandth of an inch. Right, a thousandth of an inch on the compound is a thousandth of an inch on the pitch diameter, so it's much more predictable. Okay, so we're going to dial it in with that at the very end, but we're going to be taking very shallow 1/1000th of an inch cuts. So things like this are really the reason why we give you these notepads, because it's going to be awfully difficult to keep track of all of those numbers. Okay, so let me go ahead and write those down. And then we're going to take some cuts of 1/1000ths on the cross slide. Okay. And I'm also not just going to trust these numbers, right? These are just numbers from a chart. But there are lots of different variables here, like what size is the major diameter that we cut, right? So our starting position, right? That's going to affect the ultimate depth that we're going to feed this thing. Or how heavy was my touch off, right? Things like that will affect how deep you're actually going to have to go, right? Or even things like the thread form is going to affect what the ultimate pitch diameter is going to be depending on the depth that you go in, right? Like the wires or whatever are going to be sitting lower on the threads if the threads are wider than if they're more narrow. Okay, so there's a lot of variables here, and that's what I'm trying to say. And so actually we're going to start measuring after this point right here. Okay, before our last 3 cuts. We're going to measure, just make sure that we're on the right track still, okay? Because ultimately we're not responsible for the numbers in the chart. These are just like a starting point. We're responsible for the measurement of the actual part. It should be mentioned, and I think the operations manual mentions this, yes, that depths of cut per pass values, these values here, have to be doubled when using lathes that have a direct reading compound feed dial. So what does that mean? Remember that the cross-feed dial is graduated in thousandths of an inch on the diameter, right? So if you move the cross slide 10 thousandths, it actually only moves the tool 5 thousandths, right? Because whatever you take off of one side of the part is going to be taken off of the other side of the part, right? So 5 thousandths radially means 10 thousandths on the diameter, okay? That's how these work. But these compounds are almost always, and I say almost always, graduated so that they're, let's say, direct reading, meaning that a thousandth of an inch on the dial is a thousandth of an inch of movement. These numbers in the chart are for this style of compound, right? Where if you tell it to move 10 thousandths, it moves 10 thousandths with the tool itself, okay? That's where these numbers come from. But there are some compounds out there where 10 thousandths of an inch on the dial gives you 5 thousandths of an inch of movement. So it's kind of like a diametric graduation, diametric reading, rather than a radial reading, or what I'm calling a direct reading here. Now, the slightly confusing thing is that the operations manual calls direct reading compound dials what I would call diametric reading compound dials. And what this means is that, well, if the compound only feeds half of what you're telling it to feed, if it's reading diametrically, right, then you have to double all of these numbers in order to get the right distance with the tool. The point to get at is that these numbers are going to apply on, I think, practically all of the lathes in our shop. There's only one, the old Green LeBlond and the old Monarch. Those are the only two machines that have diametric reading compounds. Everything else, the Acras, the Sharps, all of those have direct reading, radial reading compounds, where a thousandth of an inch on the dial is a thousandth of an inch of linear movement. Okay? Important to know, but don't worry about it too much. All right, folks, I think we're ready to go. Go to the start position, start the spindle. Okay, I'm going to go back into my 0 on the cross feed. Okay, then I'm going to go in my first value, which is 10 thousandths on the compound right there. And then, by the way, it's the top number here, not the bottom number. Bottom number is metric, top number is thousandths of an inch. Okay, and I'm going to cross that off so I know that I did it. I'm also going to apply a little bit of tap magic. Okay, this is a big, broad forming cut at slow speed, so cutting oil is appropriate. And I'm going to engage the cut. By the way, you'll also see that I put my hand on the wheel of the carriage handle just to give it a little bit of drag or counter pressure, and that's because the wheel is unbalanced, okay? So this handle is on one side of the wheel and not the other, and so when the little handle here comes above the top dead center position of the wheel, it'll tend to sort of flop over a little bit, and there's a little bit of slop in there, okay? And so just to make sure that that doesn't cause any jerking in the threads, I just put my hand there to give it a little bit of drag. Small thing, may not even make that big of a difference. I've noticed it a couple of times, but it's just an easy thing to do, okay? Here we go. I'm going to engage on the 4 down here. And boom. There we go. And it's refinding that thread, which is pretty awesome. Right there. Okay, back it up 1 full revolution and back to the start. I mean, I think that's pretty amazing that it finds it every single time. Now, one thing I should mention is that, sometimes these lead screws get a little bit sticky, right? They get like a bunch of gunk in them, or maybe chips or whatever, or maybe the half nut has some old oil on it and so it gets a little bit sticky, or maybe it just gets jammed up with those chips, okay? And so sometimes it's not easy to tell when you're fully engaged with the half nut. And if you're not fully engaged with the half nut, then you're not going to be able to refine the threads every time, okay? So what I like to do is go ahead and engage the half nut in its position, And you can do this with it in neutral, by the way. Okay, engage it in its full position right there. And then we're going to go ahead and mark where that position is, right? Just with like a paint marker or something so that we have a reference point. So when the two marks line up, then we know that we're fully engaged with the half nut. Okay, something like this, like right there, okay? Just so that we know that when those two marks line up, then we're fully engaged. Okay, put this back into gear, turn it back on. Okay, so let's go back into our 0 and take the next cut, which is going to be an 8/1000ths cut. So now I'm at the 18 on the dial on the compound. Let's wait until the 4 comes around. And there we go. Fully engaged right there. Looks like it's finding that thread again. Looking very good. So what do you do if the half nut or the lead screw are gummed up and dirty, right? You can always move the carriage out of the way and then so that you can access the lead screw, and then just take a wire brush to it and clean it up, okay? We often do that, and then you can re-lubricate it with a little bit of Way Lube. All right, it really does help. Next cut on here. There's our 0. We're going to take a 6/1000ths cut. Okay, so now I'm at the 24 on the compound. By the way, when you're engaging the half nut using the position of the chasing dial, you don't have to engage it on the same position every time, right? Like let's say I do it on 4 last time, but I can do it on 1, 2, 3 this time, or any of those marks in between those numbers, okay? Doesn't have to be the same one every time. There's a little bit of a superstition amongst machinists that if you don't engage it on the same position every time, then you're going to lose accuracy of the threads, which is just totally not true. That's not how this mechanism works. So let's go to, well, I'll just wait until number 1 just to prove the point. And here we go. Still finding that thread, looking good. Okay. Back it off, back to the beginning, back into my over traveled. Back into my 0. Now we're going to take a 5/1000ths cut. So that's right there. Some more tap magic on here. Okay. I'll engage it here this time, just as long as those two paint marks line up. Stop it. Back at 1 rev. Over to my start position again. Back into my 0. Okay, now I've got another 5/1000ths cut to go. Then I'm going to start measuring. So I'm at the 34 right now. You can see that the cuts are getting bigger and bigger and bigger. Okay, back into my 0. Now here's the thing, right? Those cuts are getting so big now that it's very likely that there's a little bit of deflection either in the part, in the setup, or on the tool, right? So it could be that the tool is getting pushed away or the part is getting pushed away. Right, so I'm not taking the full amount of material that I should be at this depth. And so what I'm going to do now before I start measuring, to make sure that I'm taking a good measurement off of where the tool is actually cutting, I'm going to do what's called a spring pass. Right, so with all of the settings at exactly the same location, I'm just going to take another cut and see if it removes any material. Wait for the 2, and there we go. Yeah, so it's shaving off a tiny amount of material, not very much. So that's good. That means that our tool is sharp and our setup is relatively rigid. Very good. All right. Okay, to clean up all of that shmoo on the threads so that we can take a measurement, just going to use a wire brush like so. Get it all out there. Okay, nice. Then turn off the spindle. Now we can already tell that we are nowhere near where we need to be on these threads because the crests of the threads are still pretty wide, right? So as you start taking cuts, the crests get smaller and smaller and smaller and smaller until you're done, right? There should be still a little bit of a flat top on them, okay? But definitely less than this, okay? But we should still start measuring. So I'm going to start off using this pitch micrometer, okay, because it's so convenient. And when I'm taking these roughing cuts, and I'm not even really very close at all, then there's no point in taking a more accurate measurement than this. You know, I'll switch to the thread measuring wires at the very end just to verify the size with the last few thousandths cuts, okay, but for now I'm going to use this. Just make sure that you grab the right pitch micrometer, okay? This one is the 14 to 18 TPI range, which is the appropriate one for a 16 TPI thread, okay? You've got to use the right one, otherwise the measurement is going to be bogus. Okay, right there. Make sure that you're measuring directly across the threads. Adjust it little by little and see what the drag is like. And that feels pretty good right there. Okay, what is it telling me? It's telling me 725 plus 6, so 731. According to the print, we're supposed to be between 705 and 6/10 and 709 and 4/10, right? So what is that? 22 thousandths? Okay, that's how much more we have to go. So obviously we're going to do these cuts right here and probably a few more. Okay, let's keep taking cuts. All right, where am I right now? Okay, so I'm still above. I'm going to go back into my 0. Okay, going to take a cut of 3 thousandths on the compound. Okay, and there we go. Hopefully you notice that I'm always kind of starting, I don't know, somewhere between 1/4 of an inch and 1/2 an inch away from the beginning of the threads, okay? And that's for a couple reasons, so that I can give the lead screw like some time to kind of, orient and adjust itself, but also so that I have a little bit of a reaction time so that I can stop it if I accidentally engage in the wrong position or something like that. Okay, next cut is going to be a 2 thousandths cut. Okay, back it up, back to the start position. Okay, there's the 0 and 2 thousandths. This is my final cut on the compound, probably. I mean, if we have a lot more to go right now, I'll take another cut, but according to the numbers, this is the last cut, okay? Right there. Okay, start position. I'm going to take a spring pass, like you do, just to make sure that you're getting everything cleaned up. I'm going to clear those chips though. Okay, right there. Yeah, so that's a pretty good cut. Cutting really freely. It's very, very good. If your tool is sharp, that's what it's going to look like, and there's going to be almost no material removed during the spring pass. All right, go ahead and remove all the shmoo from inside the threads. Shmoo is, of course, a technical term. Okay, let's take a measurement. All right, using the pitch micrometer now, let's take a measurement. All right, that looks pretty, that feels good. Yep, that's about the right amount of contact that you want. Okay, so it's telling me 718 thousandths. So we have, another 9 thousandths to go. I've got 9 thousandths to go. I'm going to take 2 more cuts of 2 thousandths here on the compound, and then I'm going to start going in with my cross slide. I just want to get this a little bit closer. All right, so we'll go back into my 0 position on the cross slide. All right, give it a little tap magic. 2 thousandths on the compound. Pull it back to the starting position. Sorry folks, the camera cut out there for a moment. I actually took my second cut of 2 thousandths on the compound, and now I'm going to go ahead and take a spring pass right before I measure. Let me do that now. Okay, so not really taking anything on that spring pass. So for all the naysayers out there who claim that you've got to engage the chasing dial in the same position every single time, I don't know. What do you say to that? Okay, so I'm going to go ahead and get all that schmutz out of there. Okay, I'm going to be measuring with the thread measuring wires now, and so I need a micrometer, just a regular 0 to 1 micrometer, and make sure that you 0 set this, okay? See, because this one actually is just a little bit off. Okay, that's been adjusted, and that's looking much, much better. Okay, the other thing that you've got to do is double check that your threads are the correct size. Okay, I mean, we buy these thread measuring wires from Brown and Sharp specifically because they come, to spec within 1/10 of a thousandth of an inch, plus or minus. But over time they wear, right? So you should definitely still check them. Right, remember to check them in their center 1-inch portion. And that one says, yeah, 40 thousandths on the money. Yeah, also perfect. So these wires are ready to go. Now this can be a little bit awkward. Okay, so just be patient with it. So here I've got the 2 wires on the bottom straddling one of the threads. Okay, then I'm going to put the measuring wire, the third measuring wire here, in between 2 of the threads, right where those 2 thread measuring wires are on the bottom, and then just follow that line up to the top of the part. That way I can know that I'm 180 degrees opposed. I'm going to be measuring over the actual true diameter of the part. Okay, I'm going to wiggle it around a little bit and make sure I've got a good reading. Okay, that's good. Now I can remove it. Make sure that you don't drop these. The micrometer says 775 plus 4/10, so that's 779. Okay, so according to our print, when we're measuring over wires, the upper reading is 775 and 3/10. So we're at 779. We've got just a little bit less than 4 thousandths to go. Okay, remember that these numbers came from taking the pitch diameter sizes, the direct reading on the pitch diameter, and then adding the constant on that page that talked about the calculations for measuring over wires. Okay, so we converted the pitch diameter values into measurements over wires. So as long as we're within these two numbers when we measure over the wires, then we're good. It's the same thing as guaranteeing that the pitch diameter is good. Okay, so a little bit more than 4 thousandths, which I'm going to take on the cross slide. Okay, so I'm going to go back into my 0 on the cross slide. And remember, we're done with the compound now, okay? No more compound. We're going to go straight in on the cross slide. I'm going to go 2 thousandths here on the diameter, which should be 2 thousandths off of the pitch diameter, or very close to it. And engage. Right there. Back it up, 1 revolution, over to the start again, back into the 0 plus the 2 thousandths I already took, and then another 2 thousandths to get to 4 thousandths. Let's take that cut. Okay. Stop it there, back it up. Going to go to the start of the cut again and take a spring pass. So still at that 4 thousandths position. Wait for it and go. So now we're cutting equally on both sides of the tool, right? Both cutting edges, because we're going straight in. All right, we'll go ahead and clean that up. We'll take another measurement. All right, feels pretty good. And that says 750 plus 22, 772 and a half, basically. Okay, so we're at 772 and a half, and 771 and a half is the low range, 775 and 3/10 is the high range, so we're right in the middle there. The final test for this, really, is the go, no-go gauge. One thing you should definitely do is mark which one of the jaws you had the lathe dog on, okay? Because if you have to take another cut for whatever reason and you put this back in, if you put it up against the a different jaw, then you're basically going to index your threads 120 degrees because there are 3 jaws, right? And then you're going to try to take a cut and you're going to cross thread that thread and it's going to be destroyed. Okay, so here we've got the go, which is green, and the no-go, which is red. Okay, so the first thing here is to check that the go goes. Right, so let's see. Yeah, it's going really nice and smooth. There's not very much play in there at all. Okay, and it should go all the way to the other end of the threads, nice and smooth, like so. Ah, good. Good threads. So if it starts hanging up, it's probably because there's like a burr folded over or maybe like a chip or something in there, and you really need to make sure that everything is super clean. And if it actually binds at some point, don't try to force it, okay? These are not chasing dies. They are precision inspection gauges, okay? So don't try to correct the thread by jamming this on there harder, okay? You know, some of these get ruined because people are very heavy-handed with them, okay? So it's supposed to slip on really nicely. If it is binding somewhere, then that means that you have to take another cut, even if it's just a spring pass, just to clean everything up everywhere along the length of the thread, okay? So let's check the no-go now. The no-go obviously shouldn't go. All right. Okay. Oh, it goes a little bit, and then it stops. Okay, so how much is it allowed to go? right? Now, for the longest time, I thought it was like a half of a turn. But actually, it turns out, we called the manufacturer of the gauge, and they say 3 turns, 3 full turns is what you're allowed. Okay, so I'm going to judge it by that little red wax mark right there. Back it out. Okay, right there. Oh, yep, just about 1 turn, so that's good. Now, it's really important that these inspection gauges, the ring gauges, are properly set, okay? And that's not something that we do, and that's why that wax is there, okay, to prevent us from tampering with this. This is actually set at the manufacturer, or you can buy special gauges that are used to set these gauges, right? And then you have to put the wax back in there, right? So you melt the wax out and then you put the wax back in, just so that people don't tamper with it. In the past, we've had these go out of spec, and we even sent it back to the manufacturer, and they sent it back to us small. So then we had to go in and buy the gauges ourselves to set these gauges, and so we ended up doing it ourselves. But it was pretty disappointing because we spent, you know, many hundreds of dollars getting the manufacturer to reset them, and they sent it back to us under the specification. So in order to get this GO gauge to go, you actually had to undercut your threads. The pitch diameter was too small. So there you go. Okay, I'm going to go ahead and cut the 5/8 11 threads now, but I'm going to do a lot less talking and just kind of go through the process just so that you can see it from start to finish relatively quickly. Dicom is applied. Okay, so for 11 threads per inch, that's LBT4V, L for low, B, T, 4V. Okay, right there. And I'm going to call that my 0 on the dial. Remember that on the chasing dial, when we're doing 11 threads per inch, we have to be in a numbered position, 1, 2, 3, or 4. Right there. And stop. Okay, let me test out the 11 TPI leaf on the thread pitch gauge there, and that looks like it lines up very, very nicely. Okay, good. Okay, so for 11 TPI, we're going to be in this row right here. So we're going to do a cut of 15, 10, 8, 7, 7, 6, 4, 3, 2. And then we're going to take some finished cuts of 1/1000ths of an inch on the cross slide. And I think I'll start measuring like maybe back here after this 6/1000ths cut. So this is what I've got on the notepad. All these cuts start measuring after the 6. I'll start going in on the cross slide after this 2. Let's take some cuts. I'm going to take a cut at 15. Give it some coolant. Take another cut of 10/1000ths. Right there. Okay, now a cut of 8. A cut of 7. Is that not amazing that it keeps refinding that thread every single time? Another cut of 7. And a cut of 6. I'm going to take a spring pass. A little bit more tool deflection on this one because the threads are so large. So let me clean that up and we'll take a measurement. Okay, so now I'm going to use the pitch micrometer and I got to make sure I grab the 10 to 13 range. Okay, that feels good. That's telling me 575 plus almost 20, so 595, so actually 594 and a little change. Okay, so for the 5/8 11 threads, the pitch diameter is, upper limit is 564 and 4, and lower limit is 558 and 9. So yeah, I have about 30/1000ths to go on this. Let me take those last 3 cuts that I had planned on doing with the compound, and then we'll see where we are. So I'm going to go another 4 thousandths. Okay, so now we're going to go 3 thousandths. Okay, and now I have one more cut of 2 thousandths. I'll take a spring pass. Okay, good. Very little deflection. Okay, let's measure that. All right, that feels good right there. 575 plus 3 and something, so 578 and a half, let's say. So I'm at 578 and a half, and I have to be at 564 and 4. I've got about 14 thousandths left to go. So let me take a cut of 3 and a cut of 2 on the compound. So another cut of 3 on the compound. And now we'll take a cut of 2. Wow, that was a big cut. Okay, spring pass. All right, let's measure. Okay, I'm bringing out the thread measuring wires now. These are the 55 thousandths wires, okay? And I've already measured them, and they measure, yeah, right on the money again. All right, what does that say? $656 thousandths over wires. So the measurement over wires for the 5/8 is supposed to be 645 and 2 up to 650 and 7. So if we're at 656, yeah, we have, well, just a little bit over 5 thousandths left to go, right? So I'm going to take that all on the cross slide now, okay? So I'm done with the compound. So I'm going to go into my 0 plus, well, I'm going to go 2. Now I'm going to go to the 4. I'm going to take a spring pass at 4 and remeasure. $651.5. Okay, so that's where we expected it to be. It's good to have that confirmation. I've got another, let's say, 1 thousandths to go. I'm actually going to take a 2 thousandths cut, just so I can make sure that I'm within that range. Okay, so I was at 4. Here's another cut of 2, so I'm at the 6 now. Bombs away. And then a spring pass. Okay, let's check that. $650 and what does that say? 1 or 2 tenths. So we're at 650 and 1/10 of a thousandth of an inch. That's good. Done. All right, no need to go any further. If it's in tolerance, it's in tolerance. If you go trying to cut it again just to get it closer to the middle of the range or something like that, you're just going to run the risk of screwing it up. To a machinist, perfection is defined as in tolerance. The tolerance is there for a reason. It means that this thing is going to mate with its mating component, right? As long as it's inside of that range. So if it's in the range, it's done. It's perfect. Let's check it with the go, no-go gauge. Okay, so we've got the go and no-go for the 5/8 threads now. Let's check the go gauge. Whoop. Okay. It's a little snug. Kind of hangs up a little bit, almost like it's got it's like lobed or something like that. Not really sure, but yeah, not very much force at all. It goes right on. Great. And now time to check the no-go, although to be quite honest, I mean, if the go is a little bit snug, then pretty minimal chance that the no-go is going to go, but let's try it anyway. Oh, here we go. No, barely anything. Yeah. Okay, so this little part is done. Fully and completely done. And I removed the lathe dog and the copper shim, and you can see that that copper shim really did protect us from dinging up that surface. It still looks nice. Single point cutting threads on a manual lathe is definitely like a rite of passage for a machinist. It's probably the most complex geometry you can make on a lathe. I mean, let's be honest. Not every machinist, I hate to say, can actually do this. So if you've gotten this far, congratulations. So that concludes part 4, the final part of the demonstration for the threaded shaft project. We still have to go in and do a final inspection of the part, but that's going to be a separate video. So there we go. See ya.